So welcome to this latest video on 162 Maths, and in this video we're going over the AQA AS Maths past paper of June 2024, paper 1, section A, which is the pure section. Now before we get started working through section A of this paper, a little reminder that I'll include a question breakdown in the description below so you can see which topic each question refers to, and also include a link to the 162 Maths contents page which gives you easy access to the lessons and all the other exam paper walkthroughs. So let's get started on question 1. So question 1 says it is given that tan theta equals k, where k is a constant. Find tan theta plus 180, circle your answer. So for this what we need to do is, first of all, it helps if we draw or do a quick sketch of the tan graph, in which we've got lines at 90 and we've got line at 270. And the curve looks something like, or the equation I should say, looks something like this. Now if we imagine, so this is tan theta, this is theta, so if we imagine that k is here, in which this would be our first value, then plus 180 to that, or k plus 180, or theta plus 180, is going to be at this region here. So that's also going to be at k, so this is going to be at theta, and this is theta plus 180. And as you can see, the k value is going to be the same, so the option we need to circle is going to be our fourth option. Moving on to question 2, it says curve C has the equation of y equals 1 over x minus 1 squared. State the equations of the asymptotes to curve C. Tick the one box. Now for this, obviously, because we've got a reciprocal graph, y can't equal 0 and the denominator can't equal 0. So what we're looking for straight away is that y can't equal 0 and the denominator can't equal 0. Well, for that denominator to equal 0, x must equal 1. So what we're looking for is x equals 1 and y equals 0, which is our third option. Moving on to question 3, it says express root 3 plus 3 root 5 over root 5 minus root 3 in the form of a plus root b, where a and b are integers, and we need to fully justify our answer, which basically means that although you can type this straight into your calculator and it'll give you what the answer should look like, we need to make sure that we do show our full working out. Now if you've got one of the Casio calculators, let me just quickly check to see if this actually will give you the correct answer. So if I typed in root 3 plus 3 root 5 over root 5 minus root 3, it does actually give me 9 plus 2 root 15 as my final answer. So on the calc, it gives me 9 plus 2 root 15, which does flow in this in the format that they want me to write the answer. So straight away I know what my final answer should be. However, I can't just simply write that and expect to get the full marks. So for this, what we need to then do, and also I note that here we've got 2 root 15 and they just want it as one single surd. So here let's have a look at doing this properly. So we've got root 3 plus 3 root 5 over root 5 minus root 3. So for this what we need to do is rationalize the denominator. So I multiply by the denominator reversing any signs, in which I multiply it by root 5 plus root 3 over root 5 plus root 3. Then simplifying this, what do I get? Well, I'm going to get root 3 plus 3 root 5 multiplied by root 5 plus root 3 all over. Now again, if you've had enough practice of rationalised denominators, you should be able to do the denominator straight away. So that's going to be root 25 minus root 9. And then simplifying that further, we get root 15 plus root 9 plus 3 root 25 plus 3 root 15 all over, and that's going to be 5 minus 3. So then we could then start simplifying this. So root 9 is just 3. 3 root 25 is 3 times 5, which is just 15. And the other two I can't simplify. So from this, what we end up with is 15. Root 15 plus 3 root 15 is 4 root 15. Plus, and then it's 3 plus 15, which is 18. And that's all over 2. So from this, what I can then do is simplify that, in which what I end up with is 2 root 15 plus 9, which is what the calculator told me. And then all I then need to do is to convert this back into a single surd. So here, this is going to be root 15 times 4 plus 9. So that gives me an answer of root 60 plus 9. And there is my final answer. Now moving on to question 4AI, it says by using a suitable trigonometry identity, show that the equation sine theta tan theta equals 4 cos theta can be written as tan squared theta equals 4. So for this, what we need to establish is that we can write tan theta as sine theta over cos theta. So if I substitute that into this, what I end up with is sine theta over cos theta equals 4 cos theta. I can then take the cos theta over to the left hand side, which then leaves me with sine theta cos squared theta equals 4, and then I can simplify this as tan squared theta equals 4, and that is what they wanted me to show. Moving on to question 4A2, it says hence solve the equation sine theta tan theta equals 4 cos theta, where theta is between 0 and 360 inclusive of those numbers, or exclusive of those numbers I should say. So what I can note is I can rewrite this as, so sine theta tan theta equals 4 cos theta can be written as tan squared theta equals 4. So that means that tan theta equals plus or minus 2, and then it's this that I then want to solve. So from this I've got tan theta equals 2, or that tan theta equals minus 2. Now if I solve this, then what I end up with is theta is going to equal 63 degrees or 243 degrees, and if I solve this, then theta is going to equal 117 degrees or 297 degrees, and there are my 4 answers. Now to get those answers you can either use cast or you can use the graphs, but again from tan theta equals plus or minus 2 you can go straight into the equations, which will therefore give you your final answers. Moving on to 4b, it says deduce all solutions of the equation of sine 3 alpha tan 3 alpha equals 4 cos 3 alpha, where alpha is exclusive between the degrees of 0 and 180, and give your answers to the nearest degree. Now using the answers from the previous part of this question, we should be able to establish that we can write this as tan squared 3 alpha equals 4. So all they've just replaced is theta equals 3 alpha. So from this what we can then establish is that 3 alpha is going to be equal to 63 degrees, 117 degrees, and then we need to triple the range of values, so we need to times this by 3. So here I'm then going to get, using the graph or using cast, whichever you prefer, but you're going to get your angles as being these 423 and 477, and then all we then need to do is just divide all of those angles by 3, giving our final answers of 21 degrees, 39 degrees, 81 degrees, 99 degrees, 141 degrees and 159 degrees. And again, using cast or using the graph, but remember that because we've got 3 alpha, we need to multiply the wanted range by 3. Now moving on to question 5, it says that a student is looking for factors of the polynomial of f of x. They suggest that x minus 2 is a factor of f of x. The method that they use to check this suggestion is to calculate f minus 2. They correctly calculate that f of minus 2 equals 0. They conclude that their suggestion is correct. And for part A, it's asking, make one comment about the student's method. So for this, in terms of just writing, and hopefully if you're familiar with the factor theorem, that if x minus 2 is a factor, then actually f2 is a factor. So in theory, they've got the wrong sign of the 2. So this should have written, so it should have calculated f2 of x, not f of minus 2. So something along those lines would get you this one single mark. Then for part B, it then says make 2 comments about the student's conclusions. So again, your wording might be slightly different to what I'm going. So if it is slightly different, you may want to check with the official mark scheme to see if you do get this correct. But for this, what you want to do is to state something along the lines of that they don't know whether, I don't know why I've put an A in there, let me just correct that. So they don't know whether x minus 2 is a factor or not. And they could conclude that x plus 2 is a factor. Something along those lines for the 2 statements would be good enough to get you the 2 marks. Moving on to question 6, it says determine the set of values of x which satisfy the inequality of 3x squared plus 3x is greater than x plus 6. Give your answer in exact form using set notation. So for this, what we want to do is make the inequality equal to 0. Obviously, I'm going to try and keep the x squared positive, although it's not essential. So I've got plus 2x minus 6 is greater than 0. Now, this does not factorize. So we need to use the quadratic formula. Now with this, you could also use your calculator to work this out as well, because I know the A-level recommended Casio calculator does work these questions out. So in which we get answers of minus 1 plus minus root 19 over 3. So then if I draw my parabola, which we know it's going to be a positive parabola, at this point here, this is going to be minus 1 minus root 19 over 3. And this root here is going to be minus 1 plus root 19 over 3. Now, because we want it where it's greater than 0, we're looking for this region here. So therefore, I'm going to be wanting x is less than minus 1 minus root 19 over 3, and x is greater than minus 1 plus root 19 is over 3. Now, if you did leave your answer like this, because it does specify in the question that they want it using set notation, then how you write this in using set notation is like this. So we write it as x, and then we've got x is less than minus 1 minus root 19 over 3, or that x is given to be a value that's greater than minus 1 plus root 19 over 3. And something along those lines would be, so writing it like this is how we would write this in set notation. However, if you did leave your answer like this, you could potentially lose 1 mark. Moving on to question 7, it says that a triangular field of grass ABC has boundaries with lengths as follows. So AB is equal to 234 meters, BC is equal to 225 meters, and AC is 310 meters. The field is shown in the diagram below, and the question for 7a is asking us to find angle A. So to find this, hopefully what we can spot is that this is going to be using the cosine rule, because we know 3 sides and we're trying to find the angle of A. So if I start by labeling this, so this is going to be my capital A, that means that's going to be little a, this is going to be B, and that's going to be C. Using the cosine rule, I get cos x equals, and it's going to be 310 squared plus 234 squared minus 225 squared, all divided by 2 times 234 times 310, which I know that I've got the order of those mixed up, but it doesn't really matter when we're multiplying. Simplifying all of that, we get cos x equals 0.690867, and then finding the value of x, I get 46.3 degrees, and that's to 1 decimal place. Now if you have rounded it up, always state what you have rounded it up to. Moving on to 7b, it says farmers calculate the number of sheep they can keep in a field by allowing 1 sheep for every 1,200 square meters of grass. Find the maximum number of sheep that can be kept in the field ABC. So for this, first of all, what we need to do is work out the area of the triangle. And for this, we're going to use half AB sine C. So that's going to be a half multiplied by 234 multiplied by 310 multiplied by sine, and our answer for part A, which was 46.3 degrees. And if I type that all into my calculator, I get 26223, and that's meter squared. And then from this, we then need to work out the number of sheep. So what do? Well, we're going to divide 26223 by 1200, in which I get an answer of 21.85. And then for this, because we're looking at the maximum, we want to round down. So the maximum number of sheep is therefore going to be 21. Now moving on to question 8, it says it is given that ln x minus ln 3 equals 3, and for part A it's asking us to express x in terms of y in a form not involving logarithms. So for this, what we need to do is we can simplify the left hand side by writing this as ln of x over y equals 3. Then I can take the e of both sides, in which that then leaves me with x over y equals e of 3. And then I can then make x the subject by taking y to the side, so I end up with x equals y e to the 3, and there is my answer for part A. Moving on to 8b, it says it is also given that x plus y equals 10. Find the exact values of y and the exact values of x. So this is two parts of a particular question, in which if I use the answer from part A, we know that x equals y e to the 3, and we also know that y equals x over e to the 3, just making those three the subject. So if I then go on to look at finding the exact value of x, first, so swapping y and x in this equation here, we get x plus, and then it's going to be x over e to the 3 equals 10. And then I then need to simplify this so I can factorize it with respect to x. So I've got x equals 1 over e to the 3 plus 1 equals 10. So x equals, taking the bracket over to the side, 10 over 1 plus 1 over e to the 3. And just know that I'm constantly swapping the order in which I'm adding things. And then what I then need to do is just simplify this. Now, if you're good with your simplifying of fractions, then this method won't be relatively quite easy. So here we've got 1 plus e to the 3 plus, and then if I write e to the 3 over e to the 3, that then becomes 1 plus e to the 3 over e to the 3, and that's all being divided by 10. Now this bit here, I can then simplify as 10 divided by 1 plus e to the 3 over e to the 3. And then with dividing and fractions, we flip the fraction, so that becomes 10 times e to the 3 over 1 plus e to the 3, which then gives me a final answer of 10e to the 3, 1 plus e to the 3, and that is my exact value of x. Then, if I look at the exact value of y, which I'll be honest is pretty easier. Exact value of y. We get, and replacing x with y, so we know that what we got is y to the 3 plus y equals 10. Simplifying all of this, I can factorize with respect to y, so I get e to the 3 plus 1 equals 10, and so y equals 10 over e to the 3 plus 1, and there is my exact value of y. So my two answers are this and this. Moving on to question 9, it says the curve has the equation of y equals f of x, where f of x equals x multiplied by 6 minus x. And the question is asking me to find the differential of f of x. So for this, if I know that f of x is equal to 6x minus x squared just by expanding the brackets, then to differentiate this, all I do is move the power to the front and lower the power by 1, so that's then going to be 6 minus 2x, and there is my answer. Moving on to 9b, it says the diagram below shows the graph of y equals f of x. On the same diagram, sketch the gradient function of this curve, stating the coordinates of any points where the gradient function cuts the axis. So what we're plotting is we need to plot y equals 6 minus 2x. So when we know it's going to be a straight line with negative gradient, so we just need to find the intercept point. So when y equals 0, x is going to equal 3, and when x equals 0, y is going to equal 6. So if I imagine that 6 is here, and let's imagine that 3 is going to be halfway, which is there, all I then need to do is draw a straight line through those 2 points. And again, this is going to be a little bit more awkward. And I probably should write freehand, but I'd say something along those lines would be absolutely fine. But you make sure that you are stating the 6 on the y-axis and the 3 on the x-axis. Moving on to question 10, it says it is given that dy over dx equals x plus 2, 2x minus 1 all squared when x equals 6, y equals 900. And the question is asking us to find y in terms of x. So for the first thing for this particular question is what we need to do is we need to expand the brackets for this. So what we end up with is x plus 2, 2x minus 1, and 2x minus 1. Now, however which way you want to expand this, what you should end up with is 4x cubed plus 4x squared minus 7x minus 2. So that is what dy over dx equals. Now from this we can then work out what y is by integrating all of this, in which we raise the power and we divide by the new power, so that's going to be 4x to the power of 4 over 4 plus 4x cubed over 3 minus 7x squared over 2 minus 2x plus c. Then if I simplify all of that, and you may not choose to, but again you can do, we get y equals x to the power of 4 plus 4 over 3 x cubed minus 7 over 2 x squared minus 2x plus c. Now from this we then need to use our values of y and x that were given in the question, so we know what when x equals 6, y equals 900. So if we then substitute those in, we get 900 equals 6 to the power of 4 plus 4/3 6 cubed minus 7 over 2 6 squared minus 2 lots of 6 plus c. Now if I simplify all of that, what I end up with is I'm going to end up with 900. Let's try and write on a straight line. So what I end up with is 900 equals 1296 plus 288 minus 126 plus 12 plus c, and I get a c value of minus 570. So from this, all I then need to do is substitute that c value into my y value, giving me a y equation of x to the power of 4 minus 4/3 x cubed, and, well, it should be a plus rather, minus 7 over 2x squared plus 2x minus 570. So moving on to question 11, it says it is given that for a continuous function of g, that when we differentiate g and we substitute 1, we get 0. When we substitute 4 into the differential of g, we get 0. And the function for the second derivative of g is 2x minus 5. So that basically means from this, we've got a stationary point at x equals 1. We've got a stationary point at x equals 4, and this is my second differential. Now the question for A is asking determine the nature of each of the turning points at g. Well, we've got a turning point at x equals 1 and x equals 4. So to determine the nature, what I need to do is I need to substitute those x values into my second derivative. So here we've got our second derivative function of 2x minus 5. So if I then substitute the first stationary point, which is at 1, we're going to get minus 3. So therefore, we've got a maximum point at x equals 1. And when I substitute x equals 4, then I'm going to get positive 3. So therefore, it's a minimum point at x equals 4. Moving on to 11b, it says find the set of values of x for which x is an increasing function. So from the version, as we've got our second derivative as being linear, then the first derivative will be a quadratic. The original equation, therefore, is going to be a cubic graph. So it's going to look something like this. Now, based on the information for part A, we know that this point here is at 1 and this point here is at 4. And we're looking for the region of where it's increasing. So it's increasing from this region here and it's increasing from this region here. So therefore, it's going to be x is less than 1 and x is greater than 4. Moving on to our last question for section 8, says the monthly mean temperature of a city in T degrees Celsius may be modelled by the equation of T equals 15 plus 8 sine 30m minus 120 degrees, where m is the month number, counting January is 1, February is 2, etc. For 12.8, it says using the model, calculate the monthly temperature of the city for May, the 5th month. So this is basically where we're substituting m equals 5 into the equation. So what I end up with is t equals 15 plus 8 sine, and it's going to be 30 lots of 5 minus 120. Now if I type that all into my calculator, I get a t value of 19 degrees Celsius. Moving on to B, it says using this model, find the month of the highest temperature. So for this, if we look at this region here, well, the highest value that sine can be is going to be 1. So I'm looking for the month in which sine is going to be equal to 90. So for this, so the maximum value of sine is 90 degrees, where it equals 1. So therefore, m must equal 7. And again, if you're not sure about that, if we do 30x minus 120, then from this, and we want to make this equal to 90, we get 30x equals, take the 120 over, so that's going to be 110, and so x equals 7. For part 12c, it says climate change may affect the parameters of 8, 30, 120 and 15 used by this model. State with a reason which parameter would be increased because of the overall rise in temperature. Well, for this, it's going to be the 15. And this is because this will add more to the temperature for every month. Now, because the second part of the 8 sine theta, that's just the maximum that's going to be is going to be going up to -1 and 1. So the bit that's going to be the controlling part is going to be the 15, because that's what you're always going to be adding to your final answer. It then says for part Cii, it says state with a reason which parameter would be increased because of the occurrence of more extreme temperature, and that would be the 8. And this is because this will make the highest temperature, or the high temp, higher, and the lower temperatures lower. And there we go.